So Sophie is blowing up a balloon. I actually gave my class of 30 students balloons to blow up, and only 3 or 4 of them knew how to blow up a balloon. I know, probably inflated results, but here we are. So anyway, the volume of this balloon can be modeled by this equation. Great. So as the radius increases, volume also increases, but its volume is proportional to the radius cubed. All right, makes sense, 3 dimensions. Cool, and we're asked to find the radius of the balloon when the rate of change of the volume is 25 pi centimeters cubed per centimeter. So alarm bells ringing, rate of change of volume, rate of change. So that is the first derivative of volume with respect to the radius. Right, so our first step should be to find dV by dr, the rate of change of volume with respect to the radius. So looking at our volume equation, since we're differentiating with respect to r, we take the power of r, multiply it out the front, so 3 times 4 over 3, and then we reduce the power of r by 1. So 3 minus 1 gives 2. And just to simplify that, 3 divided by 3 leaves us 4 times the radius squared. And you should be yelling at your computer screen because I forgot pi. How dare I? So again, where should we put that? So that pi is a constant, right? It's kind of an annoying constant, goes on forever, but we love pi. So take 2. The 3 multiplies out the front, 4/3 pi, and we subtract 1 from the power 2. Simplifying that, 3 divided by 3 leaves us 4 pi times the radius squared. There we go. So we found the rate of change of volume. Now the question is asking, what is the radius when the rate of change of volume is 25 pi? So in for the rate of change of volume goes 25 pi, and then we are solving for the radius. Cool. So sadly we're going to divide both sides by pi, rest in peace pi, and we're left with 25 equals 4 times the radius squared. Divide both sides by 4, so the radius squared equals 25 divided by 4, and then square root both sides, so the radius equals 5, so the square root of 25 is 5, divided by the square root of 4 is 2, and when we square root, we do get plus or minus, right? 2 solutions. However, in this context, we will assume radius is positive, right? It's going outwards, so we could say therefore radius equals 5 over 2 centimeters, right? Or 2.5 centimeters. Cool. So to recap this question real quick, we were given the equation for volume in terms of radius. We then had to find the rate of change of volume with respect to radius. Right, so differentiate, and then we equated that to 25 pi because we were asked to find the radius for a given rate of change. Right, so in for dV by dr, we substituted 25 pi, and then we were able to solve for the radius. It was radius squared, so we do expect 2 solutions. However, in this context, we only took the positive solution. The negative radius just means, if it was growing out the other way. But again, in this context, we'll just take the positive solution. And so if you found the derivative and equated it to 25 pi, that is achieved. If you then went on to find the radius, that is merit.